In the last chapter, we had mentioned that when light strikes a surface, some light is reflected. Some light is transmitted. And some light is absorbed by the surface. And in the last chapter, we had focused on the part of light which is reflected by the surface. In this chapter, we will focus on the part of light which is transmitted into the other medium. When a ray of light passes from one medium to the other, there is a sudden change in its path at the interface, or the boundary of the two mediums. This is called refraction of light. It is due to refraction that when we look at the objects through a transparent medium, the scene appears to be different. But now, why does the path of light change at the boundary of two mediums? In order to understand this, let us recall our discussion from the chapter on mechanical waves, where we had seen that the speed of wave on a string depends on the linear mass density of string. So for a constant tension, speed on string is inversely proportional to the linear mass density of string. That is, speed of wave will be higher on a lighter string and will be lower on a heavier string. Now let us consider a string where two strings with different mass densities are joined together. When a wave coming from a lighter string is transmitted to the heavier string, its speed decreases. However, since frequency of the wave is determined by the source, so frequency remains the same. So if we write the speed of wave in terms of the frequency and wavelength, then we can say that wavelength of wave also decreases. So when the wave passes from one medium to the other, its speed, or wavelength, changes. However, note that in spite of the change in wavelength and speed, boundary of the two mediums remains continuous. That is, we cannot have a situation where the boundary on the either side is split to have two different positions. Now, if the same case is observed on a sheet of cloth instead of a string, we will have the same effect as long as the wavefronts are parallel to the boundary of mediums. But now, let us consider a wave which is not parallel to the boundary. In this case, the part of wave which is transmitted to the other medium starts to move slowly. If there was no change in the medium, then this wave would have been like this. And because of the difference in the speed, this distance will increase the time. Also, wavelength of wave changes in proportion to the speed of wave. So this wave will have a shorter wavelength as well as a slower speed. However, note that we cannot have a situation like this, because this would mean that the interface would be discontinuous. so this wave of shorter wavelength must be oriented such that there is a continuity at the interface, or the boundary. So a wave coming from a lighter medium and passing into a heavier medium will look like this. In terms of rays, we can say that when a ray of light passes from one medium to the other, there is a sudden change in its path at the interface, or the boundary of two mediums. Note that here we have taken the example of a mechanical wave, because a three-dimensional electromagnetic wave, like light, is very difficult to represent. But the same discussion is applicable to both mechanical and electromagnetic waves. However, the meaning of a lighter medium or a heavier medium may be different for different waves, which will be discussed in the next section.